Okay, for our last section of the course, we're going to look at what are called parametric equations. So parametric equations are a set of equations. So it's two equations, I guess it could be more, that specifically define x and y in terms of a third variable, which we call the parameter. And most times for the parameter, we use the variable t. Doesn't have to be the variable t, but this is one we typically will use. So what happens is x and y move independently based on a third variable. So we will have an x and a y equation that will move with some other variable. So we give a very simple set of parametric equations like this. So for this one, the t is the same as the x, but then the y is double that. So if I have t equal to 1, then I know the point that must be on my graph is 1, 2, because t in for t is 1, and y would be t times 2, or 1 times 2, so 1, 2, or 2, 4, or 3, 6. So these would all be points that would be on this graph for different t's, t1, t2, t3. So when you have a set of parametric equations, it's really simple to graph it based on a set of parametric equations. So for what we're going to do, this will be pretty straightforward. So let's go ahead and use the plot pointing graph on the plane curve described by this set of parametric equations below. So we have two parametric equations, x equals t minus 1, y equals 3t minus 2, and here you can see a definition on t. We only want to use t values that are between negative 3 and 2. So the easiest way to do this is just set up a table. So my t values are going to be everywhere from negative 3 to 2, and there are values in between. You could use a 0.5 for a parameter, but I'll just use the integer values. And then we'll figure out the x, and we'll figure out the y, and then we'll know our ordered pairs x, y. So remember, x is always going to be t minus 1, y is going to be 3t minus 2. So we're just really plugging that in. So the x's will be negative 4, negative 3. They're just one less than all of them. So just one less for all my x's. Now my y's, I have to take 3 times that t and subtract 2. So 3 times negative 3 is negative 9. Negative 9 minus 2 is negative 11. So I know my first point is negative 4, negative 11. So I can go ahead and plot that on my graph. It's a solid dot somewhere down here. And these, the cool thing about parametric equations, you can literally stop them and start them anywhere you want. So for negative 2, we're doing 3 times negative 2, which is negative 6, minus 2, which is negative 8. So we get the point negative 3, negative 8. So negative 3, negative 8 will be here. So for negative 1, we get 3 times negative 1 minus 2, which is negative 5. So negative 2, negative 5. 3 times 0 is 0 minus 2 is negative 2. So that's negative 1, negative 2. So negative 2, negative 5, negative 1, negative 2. For parameter of 1, 3 times 1 is 3. 3 minus 2 is 1. So 0, 1. And finally, for a parameter of 2, we get 6 minus 2, which is 4. So we have the point 1, 4. Now, it's very important that we remember the order we did these points, because when we connect the dots, like this, that's fine. But what's important is that actually will show motion from the first point to the last point, which we denote with these arrows. So in a parametric equation, just like our world, you can have things that move up or they move down. So I could actually make this flow the other direction. But for this one, I just want to make it flow in this direction. So that's what we do for our orientation. So obviously, these set of parametric equations make a line. If I wanted to know what line it is, we certainly could do that. We could figure out what our line is. So if I do the set of parametric equations, one thing that we'll like to do is find out what the rectangular graph is. And so this is a pretty easy one to start doing that. So what I'll do is I'll just take one of them and I'll get t by itself. This one seems pretty easy. I'll just add one and make t by itself. And then I can plug that into the other equation. So y is going to equal 3 times x plus 1 minus 2. So that's going to be 3x plus 1. Now, the only difference is, remember, this equation would go on forever and ever and ever. This is a line that's infinitely long. But our line only stops here and starts there. So what I'll do is I'll define this to say, if I look at my x's here, my x's only go from -4 to 1. So I will restrict this to only have x's between -4 and 1. So this would have the same equation as this one. It just wouldn't have the orientation and the direction. You can also graph parametric equations on the graphing calculator. I'll post a separate quick video on that. But you can practice some of these on the calculator. It's a different mode on the calculator, but nothing too crazy. Let's look at a second one. Here we have two parametric equations, x equals t squared, and y equals the square root of 2 minus t, and t is going to be between -5 and 2. So I'm going to set up another table with t and x and y, and then my final ordered pairs x, y. So my t's are going from -5. You don't have to do them all. You're certainly welcome to do them all. 0, we'll do 2. So we'll do something like this. So my t, or my x, is t squared, so I'll square all these. So 25, 16, 4, 1, 0, 4. Those are my squares. And my y's are the square root of 2 minus t. Well, 2 minus -5 is 7, so y is the square root of 7. So my first point is 25 comma square root of 7. So that's going to be square root of 7 between 2 and 3, so it's way out here. So there's my starting point, way out here. For -4, 2 minus -4 is 6, so this is the square root of 6. So 16 square root of 6. So that would be, I don't know, somewhere a little lower, not much lower, something like that. For -2, 2 minus -2 is 4, so the square root of 4 is 2, so there's a nice one. So we have 4, -2. So 4, 2, pardon me. I'm not sure why I put negative. 4, 2. So 4, 2 is right there. So you can kind of see our curve is going this way. For -1, we get 2 minus -1, which is 3, so this is the square root of 3. So this is going to be 1 comma square root of 3. For 0, it'll be the square root of 2. And for 2, it will just be 0, because it's the square root of 0. So we get 0 square root of 2, and we get 4, 0. So what you'll see happen is the last one we did was the 4, 2. So we have one radical 3, somewhere like there, so it continues here. But now what happens, we'll go to 0 radical 2, which is like here, but then we go back to 4, 0. So it turns and goes back that way and stops. So what you can see is it flows this way and then turns around and goes this way and stops at 4, 0. So that is our parametric equation defined by those set of equations. Now you can obviously plug that in when we do the graphing part and check that in your calculator just to make sure you got the similar equation. So graphing not too bad with parametric equations. So let's just go ahead and practice how we could switch these to rectangular. We did one in the first one, remember, when we solved one equation for t and plugged in the other. So we could do that again. And make your life easy. You just have to kind of figure out which one would be the easiest. In this case, I can see solving for t in the first one or the second one. But just because I don't like square roots, I'm going to solve for t in this one by squaring both sides. So that'll give me y squared equal t plus 3. And so then t is y squared minus 3. So now when I plug it in, I know I'll have some kind of square equation. So that'll end me up with x equals 3 times y squared minus 3 minus 4. And then I'll simplify that by distributing the 3. So 3y squared minus 9 minus just 4. So x equals 3y squared minus 13. So we could fiddle this around. We could get y squared by itself, but I know this is a parabola. And it's going to open to the right because it's positive on the y squared. So this one is a parabola from our conic sections that we did in the last couple sections. So solve for t in one, plug it in the other. More of like a substitution problem than anything else. Now some parametric equations would be very, very difficult to get t by itself. If you have x equal -2 plus cosine t, then solving for t would involve inverse cosines and all kinds of mess. So sometimes we'll have to relate it with another equation we know. So in this case, since I see sine and cosine, I can rewrite this as sine t equals y minus 2, and cosine t is x plus 2. So at least I have the sine and cosine t by itself, which is good because we know how sine and cosine are always related. So if you can use another relationship, since like this one with the Pythagorean identity, then you can substitute that in yourself. So that is a nice thing that you can do. So if I do that, sine t is y minus 2, so I get y minus 2 squared plus cosine squared, which is x plus 2 squared, equals 1. Hopefully you recognize this. This is a circle with a center, -2, 2, and a radius of 1. So if you graph this on your graphing calculator, you should see that kind of equation. Finally, we can also convert rectangular to parametric equations before. So if I have a rectangular equation, something with x, y, I can make it a parametric equation. So here's an example. It says find the set of parametric equation for the line that passes through 6, -4, and -2, 1. Well, first I have to find that equation. Well, since this is a line, I can go ahead and just find the slope. So remember, slope is the subtraction of the y's over the subtraction of the x's. So that is going to be -5 over 8. Then I have to find my y-intercept. So to do that, and you use this a lot in calculus, so a good thing to review, y equals mx plus b. So I know the slope is -5/8. And then I could just pick any of my xy ordered pairs. I'll pick this one. So I'll pick x of 2 and y of 1, and then I can solve for b. So that's b equals 5/4 if I reduce. It's 10/8, which is 5/4, equals 1. So I'll subtract 5/4 from both sides, and I'll get -1/4. So my line equation is -5/8x minus 1/4. Now, as far as my parameter, if I want to make it a parametric equation, I can really pick anything I want. So for example, if I want to make my parameter, let's say I pick it, well, the easiest one is just to pick x equal to t, and y would equal -5/8 t minus 1/4. But that's kind of obvious because you're just replacing the one variable with another. Let's say I do x equal 2t. If I do x equal 2t, then I want to figure out something that when I plug that in, that would make that true. So this would be -5, and it would be over 4t minus 1/4. Now the reason it's 5/4 is if I look at putting 2t in for x, If I put 2t in for that, then the 2 would cancel with that and give me 4. So that's why I have this set of equations. So this is our first video. Again, I'll post another quick video that talks about how to use your graphing calculator, but as long as you can graph parametric equations and convert them, you're in good shape.